mass times gravity times h. We need to clear for h. The equation will remain as potential energy over mass times gravity equals h. So we need to find the kinetic energy at the bottom of the hill, and it is kinetic energy is equals to 1/2 times mass times velocity squared, and the substitute is equals 1/2 times 50 kilograms times 5 squared. So the answer is going to be 625. So at the bottom of the hill, the potential energy is equals to 0, and the kinetic energy at the top is equals to 0, and the potential energy is equals to 625. As we already know the value of potential energy, we can substitute all our values in this clear equation. So potential energy is 625 joules over the mass, which is 50 kilograms, times gravity, 9.8 meters over second squared. And the answer is 1.28. So now we know that the height of the hill is equals to 1.28 meters.
To make the problem big, that is how much power was developed by gravity. First, we're going to find the force, that the formula is F equals mass times gravity. Then substitute the letters, that is 50 kilograms times 9.8 meters per second squared. So force is 490 newtons. And then we're going to use the formula of power, that is weight times over time. That weight is the same as force times distance over time. And we're going to make the final velocity equals to the initial plus gravity times time. That will be 5 equals to 0 plus 9.8 times time. And then we're going to leave the t alone. That will be t equals 5 over 9.8. So we're going to substitute the numbers. That will be P equals to 490 newtons times 1.28, that is the height, over 0.51. That is the answer of time. And finally, our answer will be the power equals to 1229.8 joules.
First of all, we are going to calculate the potential energy when the cart is up, because the potential energy when the cart is up will be equal to the kinetic energy when the cart is in the bottom. The formula of the potential energy is the next: mass times gravity times height is equals, with our information, is equal to 150 kilograms times 9.8 meters per second to the square times 97 meters, and the result is 142,590 joules. That is the potential energy when the cart is up, and that will in the kinetic energy when the cart is in the bottom is equal to the potential energy when the cart is up, 142,590 joules. To obtain the speed, we clear the formula of the kinetic energy. The formula of the kinetic energy is equal to 1/2 of mass times velocity to the square, and the final formula is velocity is equal to square root of all this operation, 2 times kinetic energy over divided by mass, and that is equal to square root of 2 times 142,590 joules divided by 150 kilograms. And the final result, the velocity when the car is in the bottom, is equal to 43.6 meters per second.
In order to solve letter B, we have to use this equation, which says root square of 2 times kinetic energy divided by mass is equal to velocity. So we had to use our drawing to find the kinetic energy, which is 71,295 joules. So we just then put it in the formula. So we got the root square of 2 times 71,295 divided by 150, which is the mass, is equal to velocity, and the result we got is 30.83 meters per second is equal to velocity in the middle of the track.